Welcome to the Fintech and Payment Network session. The session is composed of two subsessions. Within the first subsession, we will first look into the current payment network to understand it. Then, during the second subsession, we will discuss how the introduction of fintech companies affected traditional payment networks. What you see on the screen is a brief table of contents for the first subsession. We need to go back a bit to the past to understand banking services that led to the introduction of payment networks. Then, characteristics of payment systems will be discussed. Let's begin. First, we'll briefly look into how banking services improved over time. According to Wikipedia, a bank is a financial institution that accepts deposits from the public and while simultaneously making loans. Banks were introduced in BC 2000 in Babylonia, but a modern bank was introduced during medieval. These are very simple definitions of a bank, and I'm sure that all of you understand what they mean. Back in the old days, a customer visited a branch where he or she opened an account for banking services. I'm not sure if you remember, but about 30 years ago, I remember that if I wanted to withdraw cash or transfer cash to someone, I had to physically visit a branch and wait in line to get banking services. For some banking services, such as closing an account, I had to visit the branch where I opened the account. This diagram depicts what the banking services were like 30 years ago. As you can see on the diagram, each branch managed a pool of customers and accounts, and a customer was bound to a certain branch. This very old style of banking service can still be found in some countries. When a customer requests a fund transfer, he or she needs to specify a branch code of the recipient's account. This divided banking service was mostly due to the lack of information technologies at that time. Well, if bookkeeping was done manually, then branch-wise management of customers and accounts makes sense. However, as information technologies were rapidly introduced to almost all areas, the branch-wise management had been quickly replaced with bank-wise management. Under this, customers could visit any branch for any banking services, and this is a common sense these days. Furthermore, the need for interbank services arose among customers as well. Not only they wanted to visit any branches, but they also wanted to visit branches of other banks for services. For instance, it would be nice if one can use an ATM at other banks to withdraw cash from an account that is managed by a different bank. As discussed, the need for interbank service arose. However, for interbank services, a means to exchange information and data among banks is required. And this eventually led to the introduction of payment networks. For interbank services, what first came into mind was connecting each bank. As the diagram shows, Bank A and B signed an agreement to connect their systems so that information and data can be sent and received between two banks. This one-by-one connection is straightforward and can be established by a mutual agreement. However, what would happen when there are multiple banks? As one can easily guess, when there are multiple banks, the connections become very complicated and messy. When 6 banks are trying to establish mutual connections, there should be 15 connections, and in terms of a bank, it needs to maintain 5 channels with different communication protocols. In overview, maintenance of communication channels and protocols can be very cumbersome. To overcome the complication of mutual communication channels, a payment network or switch is introduced. As you can see, a switch resides in the middle of all banks and is in charge of exchanging information among banks. Under this scheme, in terms of a bank, it only needs to maintain a single communication channel. The introduction of a payment switch obviously reduced the number of communication channels and burden on each bank. The payment switch has pros and cons. First of all, it is more efficient as the number of communication channels decreases. It also introduces a layer that isolates a bank from others. In other words, each bank only needs to consider communicating with the switch, regardless of the status of other banks. However, the switch can be a single point of failure. If it is down, then the entire network is down. It can only accept common features. A specialized service of a bank may not be accepted by the switch. There are certain points worth mentioning in the viewpoint of a payment network or switch. First, a participant, a bank is a trustworthy counterpart. A bank usually possesses enough IT capabilities, hence for a switch, it is less necessary to verify the trustworthiness of its counterpart. Furthermore, the switch communicates with banking systems, but it does not directly provide services to end users. Such services are managed by participants. For the switch, the number of counterparts is limited to the number of participants. This is partly because the switch does not provide services directly to end users. Lastly, the information and data format are limited to messages and files, not covering web protocols such as HTTP and HTTPS. Until now, we have seen the introduction of a traditional payment network and characteristics of it as well. From now on, we'll further dive into systematic configurations of payment networks. This diagram depicts a typical overview of a traditional payment system. The financial institution, depicted on the left side, consists of various channels for its users. The system of a financial institution is connected to the payment switch using a dedicated line, and the payment system consists of channel server, file transfer server, application server, and database server. In terms of network configuration, the diagram depicts, once again, a typical configuration. Any message or information exchange between a financial institution and payment switch is done through a dedicated line. Various internet service providers are used at the same time for high availability, and VPN is used for enhanced security. Then once a message is received at a payment system, it first passes through a router, passes L3 switches and firewall, and finally be processed by an application server. Here is a brief description of each component of payment switch. Channel server handles message exchanges to from participants, while file transfer server handles files similarly. Application server processes messages and files, and this is where the business logic runs, and database server is for storing data. Further components of a payment switch. Clustering is used for high availability, and two configurations, active and standby, are both used. Physical server partitioning is used for application and database servers to ensure stability and independence. Monitoring is applied to application and database servers, and of course, the entire system is duplicated for backup purposes. During this first session, we have looked into how old good friend banking services evolved over time and led to the introduction of a payments network. Then we checked the pros and cons, as well as characteristics of payment networks. We saw a typical configuration of payment system, as well as its components. I would like to call the payment network that we just saw as a traditional payment network, in contrast with the one which we will be discussing in the following session. I hope you enjoyed this session. And in the following session, we will look into how fintech companies changed the payment network. See you soon.